Okay, we're going to try to solve this truss problem on paper. Hopefully I stay in frame, since I can't figure out a different way to do this. Okay, this is 216, part 1 of who knows how many. So, I don't know. I opened this at home and in my Microsoft Word, and it did not format the same. So things did not end on the pages they were supposed to end on. So I was creating extra pages. If I just zoom through this real fast. You'll be able to check yours real quick. Otherwise, just have it open. Bad formatting, good formatting, doesn't really matter. This is what the last page should look like. Well, this is page 7 of 8. These are originally designed for completing the rest of the assignment. Show your work clearly, and you'll have a chance at understanding this. So we've got this truss, 10 feet wide, 3 feet tall. We got 200 pounds here at joint E, 100 pounds down at joint B. We got a pin here, a roller here, and yeah. So the first step, remember, is check for static determinacy. So 2j equals m plus r. I guess what I'm going to try to do is pause in this video, or at least, for a second. So if I ask you a question, you should probably pause the video and see if you can figure it out first. So let's see. We're trying to see if 2 times the number of joints equals the number of members plus the number of reaction forces. So, it doesn't really hurt right now to go in here and draw our reaction forces. The pin can support RAY and RAX, can resist and react in those directions, whereas the roller can only do it in the Y direction. So number of joints, A, B, C, D, E, that's 5. How many members are there? This is where you would pause if you really wanted to. You'll have other shots at this, but count the members yourself. This one would be called AD. AB, there's 2, 3, 4, 5, 6, 7. Number of reaction forces, that one should be pretty easy once you remember that pin is 2 and the roller is 1. So that's 3, so 2 times 5 equals 7 plus 3. Check. Calculate external reaction forces. This should probably not be done with a pen, but I like to live dangerously. So what it says draw a free body diagram for the entire truss structure illustrated on the previous page. See, I started out here with a dotted line, which unfortunately when I looked at it on mine, it kind of screwed that up. I have a different Microsoft Word, maybe, is the problem. He's a really old one at school. Notice I have the arrow here for that FE. For this part, again, we're doing a free body diagram for the entire truss. You can treat it just like one solid object, one solid trapezoid. Everything else doesn't matter. We're just looking for external stuff. So I've changed this to try to make it easier but still useful. And another thing I don't like is how my L's look like 1, so it looks like 200 and actually it looks like 20,016. So I recommend putting a little space in there, but I probably remember to. Now it says make sure to include all known, those guys, and unknown forces are reaction forces. Assume all reaction forces are acting inward unless it's very obviously not. So that's what we did on the last page. We assumed acting inward, acting inward, acting inward. But when we look at this, we can see that RAX cannot be acting to the right because we only have a rightward force to begin with. So it must react to the left. Now, do we know about RAY? Do we know about RCY? No, we don't. So we just act inward towards the truss. And as we talked about, if it comes out negative, that means you drew it in the wrong direction. We know at least one of them's got to be pushing up because of FB is acting downward. Pencil would be a good idea for a smart guy. Luckily, he got me. Okay. Now what does it say? It says include all angles and distances. So I'm just going to draw some dotted lines in here like they had on the other page. This is 2, this is 3, this is 3, this is 2, this is 3. These are all 3. Okay. So we need those distances only to figure out our angles here. So we got this angle here, and we got this angle here, this angle here, this angle here. We'll need those later. So we got this triangle, 3 high, 2 across. So if you would pause the video and figure out what this angle is equal to, that would be great. Do I still have a calculator on my old phone? Yeah, I do. Ah, crap. Well, I'm just gonna, I don't need a calculator. So this is 45 degrees. What's going on here? Something just went dark. Where can I draw this? So we have this theta. So let me draw it up here. Theta equals, the tangent of theta equals opposite of it divided by the adjacent. So if I take the inverse tangent of 3 over 2, I should get 56.31. And you could come up here and write what this angle is up here. It's just 90 minus 56.31. This is going to be 45. 56.31. Remember, the danger with tangent is actually you accidentally take adjacent over opposite, but then you would get your 33.69. Did I do that right? You would get that, and you should be able to recognize which one is the angle that's larger than 45 and which one is the angle that's shorter than 45. Okay, that's 8 minutes already. Wow. Let's just look at the next part, and then maybe I'll stop the video and start a new one. So we need to now look at the overall state of it. We need to use our 3 equilibrium equations. So question is, what are those again? Remind yourself. Remember that in our slideshow today we had slide 14, maybe, that had all our steps for solving. Again, this is all stuff we've done so far. So we're just going to do it again for this truss, and then we'll take the step further and go into the method of joints.